Mm-hmm.
Hello everyone, I hope you're doing well. In this video, I'm going to solve problem 10 from chapter 4 of Introduction to Statistical Mechanics by Roger Bowley. Let's see the problem statement and we'll dive directly into the solution. The statement says that the entropy of black body radiation is given by the formula. The formula is given and where sigma is a constant, this sigma. Determine the temperature of the radiation and show that PV equals U by 3. So they are the two things that we need to do in this problem. The first thing is to determine the temperature of the radiation, and the second thing is to prove that PV equals U by 3. Alright, so let's see how we can do that. Let's quickly get started with the solution. We were given with this expression for entropy of blackbody radiation, so we can write that given that this is the entropy of the blackbody radiation, which is 4 by 3 sigma V to the power 1 by 4 and U to the power 3 by 4. So let's see how we can use this expression to find out the temperature of the blackbody radiation. First of all, we'll mention the relation. We know that the temperature and entropy are related as temperature T and entropy S are related as, this is the formula that relates the temperature and entropy of the body. So that is actually, 1 over T. 1 over T equals partial S by partial U, keeping the volume constant. Alright, so this is the formula. Here T is the temperature, S is the entropy, U is the energy, and V is the volume. And that is the formula that we are going to use. We can call it as equation number 1. Putting values. So we have 1 over T equals partial by partial U. You don't need to write V in here because we now acknowledge that V is kept constant in this differentiation. So partial by partial U, S. S is this. So putting values in here, 4 by 3 sigma, which is constant, V to the power 1 by 4, U to the power 3 by 4. Alright, so 1 over T. Since it's the partial derivative with respect to U, all of the quantities will be considered constant except U. So we can take 4 by 3 sigma and V to the power 1 by 4 outside of this differentiation. So partial by partial U will be simply applied on U to the power 3 by 4. Alright, now let's find out the differentiation here and applying the power rule, in which the power will come here as coefficient dot will reduce 1 unit power from this, okay, 3 by 4 minus 1 dot derivative of this base term upon which the power was residing, so derivative of U. It's 4 by 3 sigma V to the power 1 by 4 and it's 3 by 4 U to the power 3 by 4 minus 1. Let's find out the LCM. So it's 4, 3 minus 4. We'll see what it equals to later. Partial U by partial U is actually 1. So 3 and 3 cancels out, 4 and 4 cancels out, and we have sigma V to the power 1 by 4 and U to the power 3 minus 4 is actually minus 1 by 4 that is left in here. Now here this is U to the power minus 1 by 4. We can take it in the denominator to make the power positive. So it's U to the power 1 by 4. And it's 1 over T and we want the expression for T. So we can take reciprocal on both sides. Taking reciprocal on both sides. Because we want T in the numerator. So we get T here. Everything will be inverted. So U to the power 1 by 4 above and sigma V to the power 1 over 4 in the denominator. And this is the expression. This is the expression for the temperature. Expression for the temperature of black body radiation of black body. Since we have calculated the temperature, now let's do the second thing, which is to prove that PV equals U by 3. And we can see here that we have pressure in here, and till that point, whatever expression was given, we didn't have any pressure expression in them. For example, the entropy doesn't contain the pressure expression, you can see it, and the temperature doesn't have either. So we will be using the expression that has actually pressure in it. So I'm going to use this formula. We know that P equals T partial S by partial V. So it's actually an expression that relates pressure and entropy. And here we have U and N constant. So putting values, simply. And we can see here that there is no temperature in this final expression as well. So we can obviously put the value of temperature, this value of temperature right here as well in simplification. And I'll be doing it later. So first, let's find out the partial derivatives. Partial by partial v into s. S is 4 by 3 sigma v to the power 1 by 4 and u to the power 3 by 4. All right, and we can take all of these constants outside. So since partial derivative is with respect to v, with respect to volume, so only volume will be taken as variable. All of the other quantities are constant, so we'll take them out. 4 by 3 sigma u to the power 3 by 4, and partial by partial v will be applied on v to the power 1 by 4 only. And meanwhile, we can put the value of temperature in here, which is actually u to the power 1 by 4 by sigma v to the power 1 by 4. So we can do that in here. 4 by 3 as it is, sigma u to the power 3 by 4 as it is. And we can find out this partial derivative. So power will come as coefficient dot v to the power 1 by 4 minus 1. All right. And derivative of its base term, which is actually 1. Here 4 and 4 cancels out, sigma and sigma cancels out, and we can have this situation that u to the power 1 by 4 plus u to the power 3 by 4. So we can add these powers. Since the bases are same, u and u bases are same, powers will be added. 1 by 4 plus 3 by 4, let's do it in side work. So it's 4 by 4, which is equals to 1. So it's actually u that is left behind. Okay, it's u after simplification. We are just seeing that what we are left with, and it's v to the power 1 by 4, and it's v to the power 1 by 4 minus 1. So v to the power 1 by 4 and this 1 by 4 cancels out, and it's v to the power minus 1 that is left, and this 3 was already in the denominator, and this partial v by partial v is actually equals to 1. So we can see that what we are left with, it's uv to the power minus 1 by 3, that is equals to p. That is what we have got. Now we can take this v to the power minus 1 in the denominator, so that we have 3v to the power plus 1. So we can take this v right here into this side. It's dividing here, so it will be multiplied here. That is pv equals u by 3, and that is what we needed to prove at first place, and hence proved. That is how the problem is solved, and I hope you got it. Like, share and subscribe, and keep watching. I'll be uploading more, and if you can't find any, let me know. Goodbye, take care.